My name's Corey Gates. I'm with Icontrol Networks, CTO of Icontrol Networks. Icontrol Networks, just as a way of introduction, powers many of the solutions out there that do security integrated with smart homes. We enable large service providers to offer their solutions to their customers, and we provide integrated software solutions on top of various technologies. So today I want to talk about IPv6 and why. Doesn't IPv4 work fine, and why do I care? Well, just like this smartphone here that works just fine, right? IPv4 has a few cracks in it, a few things that are starting to fall apart in a way that means that we need to start looking at newer technologies. And IPv6 isn't even new. It's now 20 years old. And it was 1993 when the IPNG group was formed. And so we're not even talking about a new technology here. This is an old technology that now needs to come to life. And why? Well, IPv4 addresses are just no longer available. If you look at that chart, the red line, the second red line, there is the blocks left. Blocks are gone, except for unless you're in Africa, you basically cannot get an assigned block from IANA at this time. And on top of this chart showing that the use of those addresses is, the availability of those addresses is in decline. So yes, there's a few blocks left, and yes, you can still get IPv4 addresses, but that's no longer going to be true very, very soon. And then you add on top of that the expected growth in number of devices, the billions of devices that need internet connectivity. And when you add that on top of the millions of services that might potentially be out there, and again, this is in terms of number of servers that need to be able to support various services across the world, you realize that IPv4 is now past. We need to step into an IPv6 future. But then you might ask, well, why do I care? I mean, doesn't the middleware layer handle this? Well, that's true. In a lot of cases, it does. But as I found in my career, you might start off being an application developer, and one day you might be a driver developer, and one day you might be a middleware developer, depending on where you end up. And especially knowing what's going on the layers below you will really help when it comes to trying to figure out the problems that are occurring. And if you listen to the talks this morning around how we need to make it easy for developers and easy for end users to understand what's going on, you'll know that there's still challenges today around the technology and how you figure out what's going on below me. I need to, even though I may assume that the connectivity layer is there, I need to understand it to really make a difference. So I'm going to bring 4 different things I would like you guys to consider when you think about IPv6 and especially on IoT devices for the smart home, but for any application. First is an education plan. Second are the standards that are associated with IPv6 and the protocols you might be using. Third, security. And fourth, your fallback plan. So let's talk a little bit about education. I think the fact that you're here means you care about education already, but I want to approach it in 2 different ways. One, the protocol itself, and spend a little bit of time talking about IPv6, as well as some of the APIs. If you went to the session this morning on IPv6, you may have attended Thiago's session on IPv6. He went into quite a bit of detail about the APIs and a lot about the protocol. I'm not going to spend as much time in detail there, but I'm going to touch on a couple different things. So obviously, as we had mentioned, the number of IP addresses is run out. IPv6 makes IP addresses much, much larger, right? So rather than 32 bits, each are 128 bits long. But in addition to that, the header itself is simplified, so it's primarily focused on routing information, the things you need so that the routers can move traffic through the network. So it truly becomes what the internet layer needs and less about fragmentation and other things, and we'll talk a little bit about what that means. Now, normally when you think about mapping a protocol onto a layer below you, you also have to think about the layers above you, and IPv6 has the same methodology, right? There's the header itself, and you can extend it. You can add extension headers to it, but that adds complexity. Being aware of IPv6 and the protocol itself the details around it is important when you're thinking about educating yourself around IPv4 and IPv6. Now, this fact that there's different IP addresses, the space is different, means something in particular. And I want to address that, especially as you think about educating yourself around network layers and IPv6. In a way, IPv6 means you're operating on a different network. Right? You have some device and you need to get to your service in the cloud or over the internet somehow, and you might do a DNS lookup and route your packets through. That's how we've all been doing it for many, many years, and in case most of the network works that way. But now when you add IPv6, you can think of it as if there's another network essentially supporting your IPv6. Why? Well, because the routers themselves need to be able to process the IPv6 headers. So in a way, you're looking at routing through a different network than you were before. But it's even worse than that in a way, because the actual way you find out where you want to go is now changed too. So you don't use the same DNS lookup. It's a completely different DNS lookup. What about address assignment? Where do these addresses come from? Well, IPv6 adds, and I'm not going to go into a lot of detail about this, the ability to statelessly assign addresses as well as statefully assign them via DHCP. So if you're familiar with IPv4, you know that you could get addresses assigned via a DHCP server, or you could statically assign them. With IPv6, you have the ability to locally assign yourself an address that's globally routable. This happens because the way the addresses are structured is into a prefix that is the network itself, and the network prefix, the first 64 bits of the IPv6 address, and the interface ID, which is the last 64 bits. That interface ID can be assigned in a variety of ways. I've listed a couple here based on the MAC address of your interface. It can be computed from that. It could be assigned in a pseudo-random fashion so that when you are on that particular network, you have a particular address. And IPv6 has the capability of having both a link local prefix as well as a global prefix. So what does this mean? That often DHCP is in fact no longer needed. You might use it, DHCP v6 in this case, but you might not. And so where do you get things like your default route from, or your DNS, or how you get to an NTP server? Well, those now come through ICMP v6. ICMP v6 is a core part of the protocols associated with IPv6 itself, and it must be supported, and it must be available at the layer above the network. And we'll talk a little bit about what that means later in my talk. IPv6 does something interesting for link layer developers. We no longer use ARP to communicate, to figure out what's the MAC address for a device on the network. In fact, IPv6 supports its own method of getting the MAC address for a device on the network, say a Wi-Fi or an Ethernet. And it uses ICMP v6 itself. It assists with the configuration routing much more than ICMP, which is part of IPv4, did, and as well as dealing with fragmentation. Fragmentation in IPv6 happens at the origin, not at the routers. The routers are not supposed to be fragmenting packets. And so in order to do that properly, you might need to find out what is the maximum transmit size I can transmit. There is a minimum maximum that's defined in IPv6 of 1280, which is much larger than IPv4 is, but having the ability to discover that path MTU allows you to deal with fragmentation on your local end. Let's talk a little bit about multicast. That's another thing to learn about. In the past, multicast was not a requirement for IPv4. It may or may not need to be used, but it's a must for IPv6. It means that if you're a developer who's mapping something onto a custom link layer or anything like that, your link layer needs to support multicast, or you can't use IPv6 on top of it. Well, and also, the other thing has happened is broadcast is no longer possible. How do you broadcast? Well, broadcast is now mapped into just a link local multicast. Multicast now has the ability to have a scope, and a scope that actually is specific to the way that the address is structured. So I give a couple examples here. The scope can be node local, link local, realm local, site local, organization, or global. Global is not something that is currently being used, but you have the ability within the address itself to specify the scope of your multicast. And also within the ID of the multicast, you can do things like multicast to all the nodes into your local network, which is how, for example, different types of protocols find out about nodes on the local network. So on the protocol side, just a very light touch on the protocol itself. But it's important when you're thinking about designing and developing devices that are going to support IPv6 to think about how you're going to educate yourself about IPv6 at the network layer. The new addressing scheme means it's like a new network. The DNS records are different, and the way you deal with addresses are going to be different. There's also changes to some well-known protocols. IPv6 is now critical, and DHCP is less important and might not even be used. And there are actually some operating systems that don't have DHCP v6 support at all in them. And so that means that when you look at debugging your system or trying to figure out what's going on inside of your embedded system, you need to understand and be aware of what the different layers are. And as I mentioned, if you're here, learning about this type of thing is obviously important to you because that's part of what this conference is about. And there's talks here, Thiago's talk about IPv6 was in much more detail, and you can speak with him about that as well. And this was just a talk to touch on a few high-level points. Now, I'm also not going to go in a whole lot of detail about some of the APIs, but I wanted to spend a few minutes talking about that. IPv6 impacts a number of APIs. Pretty much every single language that you might use for embedded and non-embedded systems has mappings into IPv6 support. New structures or address types or things like that have been mapped into them. Even scripting languages have it. The ability to handle the errors that come up and the different types of layering that you need to do with IPv6. But in addition, it possibly will impact how you're going to do DNS lookup and how you do DNS processing. So as a way of a very simple example, here's how you might write a bind in IPv4. And as you can see in C, when you're using IPv6, the bind changes. Here's another example. So here's a Weave provider from the Weave open source set, right? This is exactly what's done by they use EVHTP, which is a lib event-based HTTP server for it. And the way they're doing the bind right now in this example provider really only allows IPv4 to be used. So if you want to use Weave on top of IPv6, if you want to make your own provider, you're going to have to modify it, change it to use IPv6. Here's just another example of how libEvent and also libEVHTP supports IPv6 natively. It's just that you need to make sure that the APIs that you're calling in a way that will cause IPv6 to be used. So here's an example of taking that Weave provider and adding a few lines to it to enable it to speak IPv6. You want to? Yes, you can. Yeah, so you can also make it bind to IPv4 and v6 at the same time. This is an example because the existing provider has IPv4 and you don't want to muck with it, so you're just adding a line to support IPv6 and calling back into the same handler. Here's an example of ensuring that you're processing IPv6. This is an example of setting a socket option that you may or may not have needed to do in the past, and that is to be able to handle IPv6 at the socket layer. So again, I'm not going to go into a lot of detail about the protocol and the APIs. There's much available both on the web and also technical training. You can get classes, and in fact, if you have a team that you're working with, I would encourage you to also include your managers and your developers in learning about IPv6, so that way everyone's on the same page about the changes that need to happen. All right, I'm going to spend just a couple minutes to talk about standards. So understanding which standards apply to your design in the specific situation that you're in is pretty important when you're thinking about IPv6 itself. And there are multiple standards related to this in different domains. Obviously, the core ones related to how you map IPv6 into the link layer, how IPv6 itself works. But there may be ones that you need to understand in terms of the transition, IPv4 to IPv6 transition standards. There's a number of ways that either you can tunnel IPv4 inside of IPv6, and do you want to do that or not? And vice versa. If your service is only available in IPv6, but the internet connectivity that you need has only IPv4 available, can you deal with that? Every once in a while, when I'm at a Starbucks or one of these places, I go and look to see, well, is IPv6 actually router announcements happening on that local net today? Nope, usually not. So you might end up in situations where even though perhaps like myself at home, I can route IPv6 network packets all the way through to the internet and back, I might not be able to do that very same thing when I move my device into a different situation. And how are you going to deal with that? And then think about how the communication standards you use are going to be affected or have been affected by IPv6. So for example, the way that you listen for HTTPS, if you're creating an access point and you want to bind, and that's how you're going to get provisioned or something like that, the URL that you use for that, it's going to maybe be different. Because if you are aware of this, I'm not sure, but putting an address inside of a URL for IPv6 is different than IPv4 in the sense that you don't just put the address there, you have to put it in brackets in order for it to isolate itself from the port. And then an example of what I gave of Weave, where you might have a provider, an example provider, that doesn't really have a mapping. Well, in the case of mapping that on top of Thread, Thread is by definition a support of IPv6. That's how it's built. And so you need to understand that when you're looking at how you map your protocols into it. And IoTivity, one of the things that IoTivity just recently, in fact, in late 2015, added support by default for IPv6. Prior to that, the IoTivity tree didn't have IPv6 support in it by default. Now it does. And so when you think about how you connect and bind and deal with the different situations with IoTivity, you need to understand the standards that are important to you. All right, I want to talk a little bit about security. Security is something that you have to consider from the start. As the speaker spoke about this morning, security, pretty much everybody mentioned security or privacy in the keynote's address, and so you would be very familiar with this. But one of the things I wanted to point out is that when you have a new network layer, it's time to re-examine security, right? It's time to take a look back. Perhaps you have a working device and you're updating it to support IPv6, Now's the time when you're doing that to take a hard look at the security of that device, especially at the network layer. Why? Well, because things have changed. So for example, you might be filtering out ICMP messages and broadcast or multicast messages because your device didn't need it before. Well, you can no longer just do that filtering at the lower layers. You need to actually, because IPv6 depends on this multicast and ICMP, you can't just simply throw those packets away. It won't work. And so because of that, you need to think about how is your security going to be affected now that I'm letting multicast in. I'm not just throwing them away by default. I'm allowing ICMP packet types to come in. I'm not just throwing them away by default. Another thing to think about is when you do have a dual stack, you can't presume that IPv6 is off. So you may have updated your stack and said, you know what, I'm not going to deal with IPv6, right? I'm just going to leave it. But I'm going to use the latest middleware that I just got. Well, you can't presume that IPv6 is off. In fact, it probably is not. It's probably on. And so you need to think about, what does that mean for my security? Perhaps there are ways and methods that packets can arrive in your device before you realize that they can come in, because you may be dealing with them as IPv4 packets, but they can still make it because of the way your middleware handles IPv6. So you need to audit and test that connectivity. Figure out what is the right way to handle the IPv6 packets, even if you don't think you're going to be using it. And auto configuration, we mentioned this earlier, that you can expose the MAC address of a device. So this has privacy concerns. Do you want to still enable that in the way that addresses get configured? There are several options for not doing that that allows you to use either fully random or pseudo-random IDs and then do duplicate address detection like is normally done with IPv6 anyways, multicast, to make sure that your address is unique. And perhaps that is the mode that you want to leave your device in and not allow for the default configuration to use the MAC address as the network interface ID. Another thing to think about is multiple addresses. This is very, very common in IPv6. On IPv4, you often just have one address. Perhaps you might have a link local address that might be there. You might perhaps have a multicast address, and obviously you had to deal with broadcast packets that would be coming in. But in IPv6, you very likely will have multiple addresses and which have multiple different meanings. And perhaps you need to deal with those. And from the security perspective, you certainly do, in the sense that when a packet comes in on a particular interface, it might come into your code in the same way, whether it came in over multicast or a unicast. And if you need to know the difference, or your security relies on some methodology around where that packet is either coming from or how it's processed, it's something to think about. And then there's a number of things to watch out for based on the changes that have happened in IPv6. So buffer overflow, the IP addresses are much larger, and you shouldn't use get address info necessarily in all cases, but there is a glib issue with get address info that had a buffer overflow at one time, and this got patched. But it's an example that where you have to think about what's happening. Your code may change, the things change in how you deal with it. And so think about how you're handling buffers, especially when you're dealing with addresses. Are there places in your code where you're assuming that an int, for instance, can hold an IP address? And that's no longer true. There are, I guess, some architectures with 128-bit ints, perhaps, but most of the stuff that we're doing on the embedded side is not that way. Packet security. So something else to think about, again, because multicast is turned on and you're going to be receiving things like router announcements or node discovery packets that are coming in over for IPv6 to determine what's going on in the network, you might have to think about securing those. So there's a couple different standards around that. For example, SEND, which is a secure way of doing node discovery, allows for cryptographically generated addresses to be used. And that might be something that you have to consider based on the way that your device is working. And then finally, fallback attacks. I'm going to talk a little bit about that. With your fallback plan, you have to have a way of thinking about when your device, as I said, is no longer in an IPv6 network. And how are you going to deal with that? Is there methods, ways that your device can be forced to go into an IPv4 mode when it really shouldn't, or to take on a security protocol that it shouldn't be using because it's not secure enough? And so can your device be forced to downgrade? So think about how that happens. So, and the fourth area I want you to consider is a fallback plan. So the question is going to come up, well, is IPv4 still really used? I'm setting up something where I'm going to use IPv6 from now on. I decided, switch. It's going to cut over. Well, it's not quite so easy. Somewhat like Schrodinger's cat, right? IPv4 is neither a dead nor alive until you look, right? When you look, then you find out, I can either use or I can't use IPv4 at that moment. And in fact, if you look at the top 10 networks by volume, it's not even half where IPv6 is used. So it's not something you're going to be able to just switch and decide, you know what, I decided I'm going to use Java instead of C, like that kind of switch. No, it's not like that. So you have to have a fallback plan. And so one of the key fallback plans that I would recommend is to look at how you can have a dual stack, have both IPv4 and IPv6. And this in many of the middleware and OS layers is already handled there. But it brings up a few questions that you need to consider when you're thinking about it. First of all, service discovery. Well, how do I know whether or not I can use IPv6 or IPv4? So one of the ways that this can happen, for instance, is to do a DNS lookup. You looked, hey, is there a quadruple A response? So I send a quadruple A message. Well, then that's great, but except for wait, do I send that over IPv4 or do I send that over IPv6? So okay, I'll send it over IPv4 and assume that that's there. Well, but what if it's not? So even the ability to find out whether or not your service is available over IPv4 or IPv6 is something you have to think about. A lot of the middleware layers handle this either by doing something like sending it on both. So IoTivity, for instance, simultaneously sends IPv6 and IPv4 packets at the same time. Related to this is how the network itself can handle it. How quickly can you discover whether or not it's routable to where you want to go? It may be that, in fact, there's an IPv6 address for the service you need to get to. And in fact, you might be able to get an IPv6 address, even a global one, in your local link network. And so you can send packets off, but then nothing happens. Why? Because something along the path in between is not handling that. And so how quickly can you do this? And what does the performance impact of that for your device or your situation? How is that going to impact the end user? And finally, we talked a lot about this, the security issues. How do you deal with the multiple interfaces? You know, if someone is sending a IPv4 packet to you, even though you know it's IPv6 that you're supposed to be communicating on, are you properly handling that? Like, is that really an error condition? And how are you dealing with those error conditions for that particular case? And then finally, usability. This is important because all of the devices in some way or another are going to get put somewhere where someone's going to have to figure out how to use them. And this is important also not just when you think about the end user, like say someone using their smartphone, you know, do they know how, do they care whether or not they're on a particular network, IPv4, IPv6, why do they care? Who should care? But in some cases, you need to actually represent this duality in some way. And it might become especially important if, as you would listen to the keynote this morning, several of them were talking about managing a large number of devices. When you're managing a large number of devices, it's going to come down to some type of metric or person using it. And when that person's using it, do they need to know whether or not that device is on an IPv4 or IPv6 network? And if they do, how do they know? And what do they know about that network? And how are you going to expose them that if perhaps it's on both and it might be using both at the same time? How do you show it? You just show it as online? Is that good enough? Or do you need to know a little bit more about it? So there's 4 different things today that we talked about. And again, this talk was primarily to encourage you to think about how IPv6 is going to impact the devices you're building and you're making. And we talked about having an education plan. Being here obviously is part of that, but also go delve deep into what are the different areas that I need for my device. Going through the standards themselves, deciding what you're going to actually use, taking security seriously from the beginning. So now you're changing your network, you're changing what you're doing. What do we need to do about the security of the system? And finally, having your fallback plan. What happens if my assumption around IPv6 is not true? What if it doesn't work? Those are the 4 areas I wanted to talk with you guys today about and consider. Can I have some time for questions? If you have questions, if you could use the mic, that'd be great. Otherwise, I can repeat the question. Yeah, it's on.
So I can't remember the name of the website, but there's a website that lists routers that are certified for IPv6, and I was actually surprised how short the list is. Does that mean the routers are there, but they just haven't gone through the certification process? Or, you know, if you go down to Fry's or something like that, you pick up a $50 router, is it going to support IPv6?
Yeah, that's a great question. Yeah, I can't specifically answer the question, but you're right. There's a set of certifications around IPv6 that IPv6 Forum, for instance, has put together. And so not every single device is certified, even if the embedded stack itself supports IPv6. So you might find, for instance, that the stack that's running on that router actually, in fact, supports IPv6, but the developer of that router hasn't bothered to turn it on, or they've disabled it in some way, or they haven't disabled it in some way. It just doesn't work as properly because it's not configured properly.
Thank you for the great presentations. So I have a question on the testing, when you have the IPv6, suppose one has to test, whether it's an IPv6 or not. Is there any methodology you adopt or any recommendations on that, please?
So recommendations around testing.
Around test, that's right.
Yeah, so that's a good point. It is important to think about the way that you test stuff. So as I mentioned earlier, I think it depends on the domain that you're specifically in, obviously, what you're doing, because you may need to cause, for instance, your device to enable only IPv6. So as you mentioned earlier, there's a way to, for example, listen on IPv4 and listen on IPv6, or listen on both simultaneously. For testing purposes, you may have to write your code in such a way where you can actually enable just IPv6 or enable just IPv4 so you can properly test the different fallback situations that need to be there. Or you need to find devices that are, routers or such that are doing that. But I would say that, my experience has been really thinking through what are the different use cases for your device and making sure that within those bounds related to the network that you're properly testing those. And the other thing to think about there is what are the metrics that you associate with your communication protocol. In other words, having the right metrics to be able to tell whether or not the IPv6 is working properly over the long haul versus v4, also as well as the number of packets are being transferred, is it properly handling errors, those types of things. So having the right metrics so that you can run it over a long period of time and be able to test it and ensure that it's continuing to work is an important thing. Any what? Tools? I'm not specifically aware of tools that do specific IPv6 testing other than the standard tools that you can use to do things like ping6 and other stuff that are standard part of the operating systems or part of the distributions that allow you to test. But in terms of testing your specific device, is the kinds of things that we've done because of the devices and that Icontrol builds, the testing that we have to do is a lot of it has to be written kind of by hand in order to be customized to the specific network. Although you can use tools, that already have IPv6 support in them, you often need to write some special custom code in order to do that. All right.
Do you have some more insight on what Apple will do with iOS in the new policy? So they had some vague statements on IPv6 will become mandatory, but I would like to know some more insight if you have them, and I can imagine you don't. But
yeah, I can't really speak for what Apple's planning to do specifically. I don't really know. But yeah, it begs exactly the question of whether or not your app, for instance, right? Let's say you have an app and you need to communicate between your app and your device in the home. And in that particular case, you might have issues where you have to resolve them. How do you deal with communication between your device, the cloud, and your home, and if they're different? So can't speak specifically as to that. I know that, for instance, there's a number of mobility extensions to IPv6 that allows some of the bigger network providers to have IPv6 networks and be able to assign addresses to them. And that in general, when that has happened, most of the time devices get assigned a single network prefix. So it's actually the first 64 bits that become the device itself. So.
Okay, thanks.
Mm-hmm. Thanks for your time. Appreciate it.